All right, folks. Well, thanks for dialing in. Again, my name is Bill Cunningham, and I am the regional manager for the eastern half of the United States for Alfa Tools. Alfa Tools is located in Morton Grove, outside Chicagoland. And today, this quick PowerPoint is really just the basics. Call it Drilling 101. The takeaway, hopefully, will be, have a little bit better understanding of what we're looking for as distributor sales folks and how to sniff out some of these things. But why don't we go ahead and get started, and let's see the next one, Todd. Okay, the introduction and the objectives, which I've kind of started on, is, twist drill bits are one of the most common products sold through the distribution channel. All channels, whether it's a staff to house, an industrial house, a welding house, everybody sells twist drills. They are used everywhere. And hopefully in this course, you will have a better understanding of the types of twist drills, the steels that they're made of, some of the terminology used to describe them, as well as some of the coatings and applications, tips and recommendations. Let's get started with the basics. Okay, twist drills are used to create round, accurate holes, not just in metal, in wood, and all kinds of materials. They are made for both handheld drills, drill presses, CNC machines, any type of tool that has a chuck and a spindle that goes around can use a twist bit. Diameters for these are obviously fractional. They're metric sizes, letter sizes, and also wire gauge sizes. As you can see on there, the different sizes are laid out usually from small to large based on their decimal equivalent. In many cases, manufacturers will show you just the fractions and then the metric and the numbers and the letters individually. Others put them in a chart based by size, small to large. Next. Okay, what are the main elements? What do you think about when someone says, hey, I need to drill a hole? Okay, what to consider to pick the right twist drill? First of all, you need to know what you're drilling, whether it's metal or wood or concrete. You need to know what you're drilling. There are different tools for different jobs. Then once we know what we're drilling, we want to consider the point of the drill. And this will be explained in the next few slides, but the spiral of the tool, the type of shank, you're going to need to, how are we going to drive this thing? Does it have a round shank, a quick change shank? The overall length, can we go deep enough? And based on the material, do we need coatings? So basic drill diagram, as you see, they're plugged in here, overall length. Let's take note, when you see the overall length toward the tip of the drill, if someone asked you, would you measure the overall length of any given drill? Proper way is not from tip to tip. It's where the point starts. The point, as you can see there, is not included in the overall length. And in many cases, this means nothing. But in some cases, machine drilling and otherwise, they need to be accurate on the overall lengths of the tool. So the shank is on the other end. Between the shank and the point is the flute length, the flutes, and then how long the flute is, the point angle, the degree of the angle, and the point diameter. This is your basic drills. So let's continue on.
Ask them.
Ask me. Oh, by the way, folks, if there are any questions, I can take them at the end, I can take them in the middle, whatever it takes. This is very informal. So twist drill bit lengths, jobber length, the most popular drill. One of your customers says, bring me a pack of 1/4-inch drills. Take them a jobber drill. Unless they specifically say they want a different tool and it's a general request, jobber is what you look for. That's the standard everyday stuff and most versatile. Next most popular is the mechanic's length. It's slightly shorter and it has 3 flats on the shank to prevent spinning of the tool. This tool was very much designed for the portable tools that have a 3-jaw chuck on the end. People are doing this all day. Diameters, the chuck will loosen and the tool will spin and you'll get a bad hole or you break the tool. So the 3 flats are what clamps down with the 3 jaws in the chuck that holds the drill. Screw machine length, also known as stub drills, is the shortest. It offers the most rigidity and strength. I heard a fun fact here a few years ago that 80% of the holes out on the market can be drilled with a screw machine length. Why does everybody buy the jobber? I don't know. They think they're getting more for the money. And in some cases you can go, obviously you can go deeper with a jobber drill. Taper length. This is a term that was derived from taper shank drills, which we'll see on another slide, but still is a straight shank drill. There's nothing taper about it. It's just longer than a jobber. The taper length throws a lot of people off when you talk about that as a description, but really what it is, it's a longer series of drill. More lengths. Aircraft extension drills come in either 6-inch overall length or 12-inch overall length. But it's got the same short flute as a jobber drill. Why would they make this? Just for reach. This is not a drill for drilling deep holes. It's for reach. Sometimes you have to get past some type of fixturing or the vise, or your part is hanging off the side. When we're talking about machine drilling, we're talking about hand drilling, you may just have to get past something to reach the hole. So aircraft extension drills are not for drilling deep holes. They are for reach. Extra length are for drilling deeper holes, and Alfa offers 8, 12, 15, and 18-inch overall lengths. These are designed to go deep, and in many cases you've got to pack in and out to clean them out, but these are the tools to go into deeper holes. Next. Okay, let's talk about the points a little bit. 118-degree point. This is your standard general purpose all day long point. Very widely used in general purpose applications. And very good for mild steels, free machining materials. It's easy to resharpen. Many of us don't resharpen drills anymore. Many end users just dump them in the high-speed bin and they recycle. But the next point, if you go ahead, is 135-degree split point. Now, this is the most popular today. Most guys, like I said, 90% of our guys using these kind of high-speed general purpose tools are doing it by hand. This point is put on, first of all cobalt drills, because they're known as heavy duty. They always split the point on a heavy duty drill. So it starts faster in the higher alloy materials, and it's self-centering. Well, what does that mean? We've all tried to drill a hole, I think, and the drill's moving all around. You didn't, make a punch to start the hole or have a smaller hole to begin with. This point won't walk around on you. It will bite right away, and it's ideal for curved surfaces. If you were drilling a piece of pipe, it might be harder to get the drill started. This will start better. Even if you have any kind of curved surface, this point will help you with your penetration. Next. Okay, the body of the twist drill is made up of 2 parts. The flutes and the lands. The flutes are the, let's call it the gullies, the flutes. They run the length of the body to carry the chips away. The land is on top, which is tapered back slightly and has the sharp cutting edge. Next. Okay, what kind of shanks? Most of what we've talked about, all of what we've talked about so far is, straight shank. Straight shank plain, straight shank with flats. We have reduced shank, which are used on the Silver and Deming drills. When we talk about a standard screw machine drill, jobber drill, these drills basically stop at 1/2 inch. Now, some European brands and Alfa specifically, we do go larger than 1/2 inch, but most of the chucks on our Milwaukees and DeWalt's are 1/2 inch capacity. So what do you do when you need to drill a 5/8 hole or a 3/4 hole or an 1/16 hole? And all you have is your portable. You use number 3, a reduced shank drill. And those drills are available up to 1.5 inches with a 1/2 inch shank. And with a 3/4 beefier shank, they're available up to 2 inch. So with this kind of tool, your portable tool, you can go from, extremely tiny up to actually 2 inch off a 1/2 inch shank. And the last one over there, which is actually kind of hidden from me, Todd, I know number 4 is a tapered shank drill. I think it's just the way I have it set up here, but tapered shank drill was the most popular drill 30 years ago. Morris taper shanks. Has nothing to do with Morris cutting tools. But there are different tapers, and the machine spindle had a taper to it, and they would put these tapered shank drills just kind of boom right up into the spindle, and the tapers matched on both, and it would stick, and then that would drive off of the tang, which is a ground on the end. Let's continue. Okay, guys, there's a lot of talk about coatings and treatments, and I'm going to tell you what's coating and what's treatment. First of all these tools are made of the substrate, or the steel they are made on are hardened and ground. So they're heat treated. Once this high-speed steel tool is heat treated properly, it's usually measured on the Rockwell C scale, HRC scale. The harder they harden them, the more wear resistance they are. But you have to be careful not to harden them too much. They become brittle and will chip out inside the hole. So what do we have next? Okay, types of steel. All right, high-speed steel, HSS is the shortened version of that. High-speed steel, most common in all drilling. So once it's hardened to ground, the hardness, HRC, 63 to 65. I think that's generous. Back in the day, we used to say 62 to 64, but a point on the Rockwell scale really means very little. But it's an ideal blend of toughness, hardness, and wear resistance to drill other metals as well as wood. Now, we talked about treatments. These tools, once they're all hardened and ground and finished, they're all bright. Tools don't end up black by accident. Black oxide, also known as steam oxide, is very popular. I think we might get into it here, and I'm going to talk a little bit more about the coatings and the treatments, but black, bright, black and gold, these are treatments. These are not coatings, and I want everyone to understand that. What do we got next? Okay, here we go down to the premium high-speed steel, cobalt. It's still high-speed steel, guys. It's just that the structure and what they put in it, in the steel itself, is different. They add cobalt. M42, that designation means 8% cobalt. There's M35s and others out there, but M42 is the premium substrate steel to make twist drills from. You see the hardness? You're about 5 points harder. Now, when cobalt first was invented, they were grinding all these drills, and how do we tell them apart? If you got a 1/4-inch drill that's bright over here and one that's bright over here, how do we know? So they came up with, for ID purposes, to use this, to draw out the tools with this straw color or gold. This is an indicator that you're looking at a cobalt drill. Now, we saw in the previous slide some black and gold drills, multicolored, that uses the same process for the gold and then adds steam oxide to it for lubricity. So colors, you know, when you guys are out there and we're looking at an end user's tool crib or a drawer full of tools, or just talking to a customer and he says what he wants, if he says cobalt, you almost don't have to, if it's a cobalt jobber, you're done. Just find out the size. You don't have to worry about, you know, the points, because cobalt are all the 135 split. So what do we have next? So again, we're talking about types of steel, and I cheated here a little bit because this isn't really steel, but solid carbide. The world of drilling is going solid carbide and has been for a long time. There's still millions and millions and millions of dollars of high-speed steel and cobalt in use in both tool room maintenance, MRO, and production. But in today's high-speed machinery and accurate spindles, solid carbide is a much better tool for the job, especially if you have lots of holes to do. So it's best suited for drilling in tougher to machine materials. If you can't drill it, for instance, if you tried to drill some H13 mold steel, which is already 62 Rockwell, how are you going to drill that with a drill that's the same hardness, 62, 64 Rockwell? You move to solid carbide and it's much harder. So it's manufactured actually just from powders. They mix powders in. Everything is pressed down by, you know, hundreds of tons into blanks. Then it's sintered in a hip furnace. And then you have these rods that are almost as hard as diamond. And diamond wheels then grind the flutes and the points into them. Then you have a solid carbide drill. Same type of items that are used in the lathe industry when everybody talks about carbide inserts. It's the same material. There are different grades and mixtures and magic powders, right, that different manufacturers use, Sandvik, Kennametal, whoever. But in the basic world, solid carbide is made from powder. And it's a higher performing tool. We have a pretty nice offering of this stuff, as well as our high speed and cobalt. It's extremely resistant to heat and wear. Go ahead. Okay, coatings. Coatings will extend the life of a twist drill. What does a coating do? It withstands heat, allowing point sharpness to last longer. The killer for a drill is heat. For instance, let's say, well, we have a picture here of some tin coated or gold coated and a couple other drills. If you take a standard high-speed twist drill, the point, corners, and the chisel edge in the middle will start to break down between 600 and 700 degrees. It's 62 Rockwell, you're reefing down on it, you're trying to drill a 1-inch deep hole in some kind of metal, heat starts to build up, you're going to dull out the tool. Okay, so coatings became very popular in the automotive and aerospace industries for high production situations, but now they're so prevalent that they're out there for general purpose uses. Let's see what we have next. Kind of talk about individually a little bit about some of these. So tin, titanium nitride. Seems like everything was based off of titanium. These coatings reduce the friction and improve life, and the chip hole and the finish. Like I said, with tin on the same tool that breaks down at 600 or 700 degrees, this can withstand 1,000 to 1,100 degrees. And it's just, what does that mean? Well, it's going to last longer. Okay, it won't break down as fast. The coatings itself are a very lubrous item, so it keeps the heat from building up. And it's a barrier. It won't, they're like 4 microns thick if this is done properly, and all these things. So you don't change the diameter of the drill, but it's a very thin film coating that adds lubricity and helps you get more tool life. So that one is gold. And by the way, if you're over in Harbor Freight or Lowe's or whatever, and they got these gold drill sets, take a good look at them versus a real tin coated drill. I mean, that's some kind of flash coating. It's not real tin. So the next one is TICN, titanium carbonitride. This one was done for high silicon aluminums and other non-ferrous tools, and then they really found out it works great in all kinds of cast iron and even alloy steel. So it has a little bit higher heat, like by a few hundred degrees over tin, and it's better in some certain applications. It's really good on tapping, and I like this coating a lot as very versatile. Some of the newest, most high-tech coatings are very specific. This one is just for machining, whether it's pure titanium or some kind of super alloy for the airframe industry. They've developed all these different coatings. Now, 4 or 5 of these coatings are just standard everyday stuff. Little kind of blue-gray or violet in color for the TICN. ALTIN. The heat resistance number, it goes way up on this. This is extremely good. Was developed for dry machining and mostly in the milling world, for milling hardened product. So ALTIN, I have a full line of carbide end mills with this coating on it. We don't have any drills within our line with this coating, but many people do. It's darker, more of a blue-black than TICN. If you hold them next to each other, you can definitely tell the difference when you're looking at them. Let's continue. So chromium nitride. So ZRN, this also extends wear, and this was developed for non-ferrous, aluminum, copper, brass, bronze, and then they find out it works pretty good in die steels as well. So that's kind of a white gold looking tool. So that's so drilling recommendations. Look, folks, you know, you guys are all good distributor folks, and if someone asks you for a recommendation and they're buying just jobber drills, this can be a whole nother class. In everybody's catalog, including ours, there are pages that offer surface footage and charts to get your RPMs, recommendations. But first, you still have to know what you're drilling. So you know your diameter. Hey, I got a 1/2-inch drill. I'm doing cold roll steel. And you know, you find that in the chart, and it might say 250 surface feet. Then you use the other charts and formulas to figure out your RPM and your feed. Now, if you're doing this, your feed is relative, right? You're pushing inch per minute. You can figure it out with a stopwatch, but look, not many people are going to ask you about speed and feeds. If they do, we'll help you. You know, the Stohler guys are, you know, are trained in this. I live here in Michigan. I can do this. You know, I'm more than happy to help anybody spec in a drill with the right speeds and feeds. But to really try and get down into this, I won't say it's not worth it, you have lots of resources with you know, the reps and the factory people and printed information. We can get this all fairly quickly. So please don't hesitate to ask for speed and feed help. What else do we have? Okay, so a little bit of handheld drilling tips. Okay, this is the easy one. Go straight in, straight in and out. Don't twist the drill around because you need a bigger hole. That's the reamer's job. I mean, we've all done it. You know, let me get in there. I can get this bolt through here. Use cutting fluid if you have some. Even if it's water for cooling, a little bit of oil, anything to help with lubricity. Any kind of fluid for cooling and lubricity will give you better tool life. Then if you're in there and you're drilling fairly deep, sometimes you have to retract the drill, clear the chips out of the flutes, and re-enter the drill into the hole. You can take it 1/3, you clear the hole altogether. This is kind of an operator thing, but you definitely have to balance the speed and feed for the drill to work properly. Let's see what else we have. Some other helpful tips for good drill life. Use the shortest drill possible. Prevent it from spinning in the chuck, which those 3 flats will do, or tighten the chuck properly. And check your speeds and feeds. Key factor is proper drilling is the feed rate. You know, heat kills, and if you're going in at the proper RPM, but you're pushing it too hard, whether it's with a drill press or by hand, you will prematurely dull out your tool. What else do we have? Okay, folks, in summary, we appreciate you taking this and dialing in. It's a pleasure for me to just kind of narrate this. And hopefully you can understand a little bit of basic terminology, you know, a shank, what's the shank, the flute, the point. Yeah, you know, the most popular types of drills. I think you have an understanding that coatings are important. Especially if the guy says, hey, I got 10,000 holes I got to do this month. Then we start talking about carbide and coatings and how do we help the customer with cost per hole instead of, hey, my drill's, you know, 89 cents. So hopefully this helps everybody who's viewing, and I appreciate your time. Thanks again.